Transfection reagents account for a roughly $700 million annual market. The main users of these are industrial and academic large-scale labs that study both protein production and cell pathway and therapeutics. Over the last 12 weeks, we've done over 20 interviews in this area and come up with an R&D roadmap that can position the technology for a good life secret of a large-scale distributor, such as Thermo Fisher Scientific. We're excited to present our results to you, and my name is Reed Grimes. I'm a second-year MBA student.
My name is Kat Hyland. I'm also a second-year MBA student here at the Rainbolt Graduate School of Business.
And I'm Lindsay Wynn. I'm a second-year medical student at the OU College of Medicine. And I'll get started today. So to begin, let's just define what transfection is. Transfection is the technique in which genetic material is introduced into a cell with the aid of a transfection agent. The need for transfection arises from the fact that genetic material cannot really diffuse across the cell membrane independently. And so a transfection agent is used to overcome this limitation by essentially acting as a cargo carrier. So here we have a diagram that demonstrates this process with the cargo being the genetic material being loaded into the cargo carrier, the transfection agent. We take that loaded transfection agent and incubate it with a whole cell line of choice, and ultimately we're able to get an end product of a successfully transfected target cell with the genetic material delivered into the intracellular space. This end product can be used for a multitude of applications. Some examples include cancer therapy, drug delivery, protein production, and examination of biological pathways. So through extensive market research and a plethora of interviews with potential end users of transfection agent products, the team has been able to identify several problems in the transfection reagent market that can be improved upon with the use of the new technology. These problems include efficiency, cost, and time. So with the available transfection agents on the market, the efficiency averages to around 70 to 85%. The typical user of transfection agents spend up to $1.5 million per year on transfection reagents or cargo, and the time needed to prepare and execute transfection can be substantial. And so the new technology is able to improve upon these points by increasing efficiency by 10 to 15%. With this increased efficiency, the amount of cargo needed to be loaded into the transfection agent can be reduced to 18% of the standard amount, thus reducing the annual cost of transfection for the agent and the cargo by $615,000 per year. And then finally, with this increased efficiency, less transfections are needed to be done to achieve the same outcome, thus decreasing the amount of time needed for transfection. So the improvement on the problems in the transfection agent market is made possible by the new technology because of the novelty of this new technology, which is the unique liposomal nanoformulation. So the transfection agents available on the market largely comprise of both cationic and anionic transfection agents. This means they have an inherent positive or negative surface charge around the transfection agent, thus limiting the amount of transfection that can be done by these reagents. So with this novel liposomal nanoformulation, we're able to achieve a net neutral surface charge of the new technology, allowing for a great improvement upon the transfection capabilities of the new technology. This is represented with a 90 to 99% efficiency, which has been tested in 3 ovarian cancer cell lines, and a cargo of silenced RNA. The inventor has obtained a provisional patent for the new technology, which through additional research and development, we hope to convert in the spring. And with that, let's pass it off to my teammate, Kat, who will discuss the market for the new technology. Thanks, Lindsay.
So in its current state, this novel transfection reagent has the potential to greatly decrease the amount of cargo required to successfully complete an efficient transfection. This is largely the area in which this technology is differentiated from competitors on the market today, but there are several other areas or criteria that will need to be compared against, which we'll talk about further in our research and development plan in order to further distinguish this technology. The reason it's so important to distinguish this technology and differentiate it from competitors is because the market is highly saturated and there are tons of competitors. 3 of the most popular competitors that we learned about through our interviews are Hi-Perfect and lipofectamine 3000, which are both liposomal nanoformulations similar to the technology we're speaking of today. And then there's also been a movement, which we've heard about, toward polymer-based reagents, which is a different type of technology, but it's been able to greatly improve on efficiency and efficacy of transfection in the market. So it's been very important to us, and we've actually talked with our inventors throughout the last 12 weeks after having learned about this move to polymer-based reagents, that they really compare directly against this PolyPlus, which is popular in the market, at least for the high-volume industry players. So right now is a really good time for our inventors to be entering this market because it's expected to witness very significant growth over the next 7 years with an expected compound annual growth rate of 7.4%, bringing the market to a $1.07 billion cap in 2025. This is largely due to the continual introduction of novel reagents like the one we're talking about today and the gradual emergence of nanotechnology and biomedical research. There are several different ways that you can break down this market, and we took a look at several different types of breakdowns, such as by method, by application, etc. The way that we ended up breaking it down that was most effective was really by end users. So we looked at the different people we were talking to in academic labs or industry labs, and then we looked at whether they're doing high volumes of transfection on a daily basis or low volumes of transfection. And really what we came to find is that these high volume industry players are really what makes up the market the most. So there's 92% in this segment, and really it's where the pot of gold is and what will need to be targeted moving forward to make the investment worthwhile. So a typical high-volume industry lab has the potential to save over $500,000 a year on transfection reagents and cargo. We spoke with a man from Genentech who works in a research lab there, and he talked to us about spending roughly $750,000 on reagents per year. And for every dollar he spends on reagents, he also has to spend an additional dollar on the cargo that he's delivering. This varies a little bit from some of the high-volume academic labs who at times create their own cargo, but it varies quite a bit. But on average, you're either spending $1 on cargo for each dollar on reagent, or you're spending a significant amount of time developing and preparing your cargo for transfection. So with that being said, with the 82% reduction in cargo required for a successful transfection, there's an opportunity to save over $600,000 on the cargo alone, plus the additional savings that are possible on reagents, which are still to be determined. Ultimately, the technology value proposition for this market segment comes down to improving the cost-to-performance ratio. So these large organizations, biotechnology companies and pharmaceutical companies like Genentech or Pfizer, they have really extensive budgets. Money alone is not really a huge issue to them, but if they can get a technology that's going to improve on their cost-to-performance ratio, they're absolutely going to switch, and they're not so worried about the switching costs that go along with that, as some of our academic interviews told us they were. So ultimately, this market segment, these industry players are really most worried about having a supply that's guaranteed, basically. So to work with a large-scale manufacturer or distributor like a Thermo Fisher Scientific or a Sigma Aldrich is really the best way to move this market move this product into the market. So I'm going to turn it over to my teammate Reed at this time to tell you a little bit more about how we recommend doing that.
Thank you. So we've determined the best way to move into the market is through a licensing agreement with a large-scale distributor such as a Thermo Fisher Scientific. The consumers tend to want things that are reliable, both in the supply and the material that they're getting. Large-scale distributors have this brand recognition and this track record. The large distributors also would like to have things such as a strong IP and pressure testing. Pressure testing is whenever you scale your method up to a large manufacturing process so that they can sell it off. And this method would make it more viable for the University of Oklahoma because you would not only be not having the researchers run a spin-off company so they can continue their research, but Oklahoma would have the continued cash flow. So how do we position this for the best licensing agreement? Well, a lot of research needs to be done, and it would take roughly $330,000 investment. This would be over a 9-month period. The first 3 months between now and when the patent is supposed to be converted would mostly be testing a handful of cell lines and scaling the project to high volumes of material. This cost would also include the original $100,000 for the international patent. After this patent and these initial trials have been completed, you would move to phase 2, which is just a larger version of it, so you can cross-compare the data. And finally, phase 3 is where you would license off into a large-scale distributor for an outside comparison and validation. OGD would see a payback in roughly 2 to 5 years. If there were only a handful of labs that adapted this and accounted for a market share of 0.25%, you can see a return on the initial investment in 5 years. However, with growing market share capping off around 2%, because there are so many competitors, you can see in year 10 roughly a $4 million revenue, with 35,000 units being produced in that year. OTD would recover the initial cost in about 3 years. The key assumptions were that the royalty from the large-scale distributor would be, on average, with that seen in the industry, roughly 5.4%, and sold at roughly average for the industry at $700 per 2 million unit buy.
So ultimately, over the past 12 weeks, we've had an awesome opportunity to conduct over 20 interviews, first person, to identify a $640 million target market. We've identified and selected a license agreement strategy to move forward with commercialization, and recommended 3 phases of R&D to our inventors, ultimately identifying a $4 million profit potential for OTD over the next 10 years. So with that, we'd love to open up the floor to any questions that you guys might have. Thank you all so much for your time today.